Welcome to Sachin Study Tech. Today topic is defective chessboard. So what is the defective chessboard? In that problem also you can apply the divide and conquer strategy. If the problem is big problem, then you can apply the divide and conquer strategy in this case. Now we can see give a chessboard of size n by n where n is the 2 power k. So the total number of squares equal to n into n, that is equal to 2 power k into 2 power k into 2 power k. So that is equal to 2 power 2k. Now we can see number of non-defective squares are only 1. So with exactly one defective square, so non-defective squares are 2 power 2k minus 1 non-defective squares. So here the non-defective square must be divisible by 3. And how can cover that non-defective square cells? So by using L-shape tiles are also called as a trominos. So now we can see the problem. For example, the total is 2 power 2k. For example, here the k equal to 0. The k value is 0. Now 2 power 2k, the k value is 0, that is 2 power 0. 2 power 0 equal to, that is 1. Only one defective square is there. Then 1 minus 1, that is non-defective squares are 0. So only one cell is there. This is the defective one. So you can fill with the defective one. So there is no non-defective cells in case of k equal to 0. For example, in case of k equal to 1, k equal to 1, that is 2 power 2 into 1, that is 2. That is equal to, so non-defective squares, you can find out the non-defective squares. 2 power 2 minus 1, that is 2 power 2, 4 minus 1, that is 3. You can see one more important point, non-defective squares must be divisible by 3. So here it can divisible by 3. 3 is divisible by 3. Now we can see the k equal to, for example 2. In that case 2 power 2k, that is 2 into 2, 4, 2 power 4, that is 16. 16 minus 1, non-defective squares, you can find out the non-defective squares. 16 minus 1, that is 15. So again the 15 is also divisible by 3. So now you can see these are the diagrams. So the k, 1 by 1 cell, this is 1 by 1 chessboard. So only one defective cell is there. There is no non-defective cells. So here 2 by 2. Here there are 4 cells is there, 4 squares. One of these 4 squares, one is the defective one. So this is the defective one. Remaining are non-defective one. So in this non-defective one, you can fill with the L-shape symbol like this. Here it is a trominos. This symbol is called as a trominos, a triminos. So these, what are the non-defective cells is there in that chessboard, you can fill with this L-shape symbol here. So non-defective cells. So for example here this is the 4 by 4, that is 16 squares is there. Out of 16, 1 is the defective square. So for example here consider this is the defective one, remaining are non-defective one. So this problem is big problem. Then this problem is divided into number of sub problems. So this problem is divided into number of sub problems, equal parts. This problem is divided into number of sub problems. This is one quadrant, this is another quadrant, this is third quadrant, this is the fourth quadrant. For example here in this third quadrant having one defective cell is there. This is the defective one. Now we can see in here these are these 3 quadrants are non-defective. There is no defective cell in that quadrants. Now we can fill with L-shape symbol here. You can fill with L-shape tiles, trominos. Here also you can see in this case, here also you can fill with L-shape symbol here. Here also you can fill with L-shape symbol. Here also you can fill with L-shape symbol. Here also you can fill with L-shape symbol. So the entire problem is solved. So the problem is big problem, then divided into subparts, sub problems. Then each and every sub problem you can solve it. So here it can see 8 by 8. So here also you can divide it into number of subparts, then you can solve it one by one. Now we can see this problem is divided into number of problems, number of subproblems. So you can see here this is also a big problem. Now this problem is, for example, you can see here in this quadrant having the defective one. Now we can field these are the these three are non-defective one. So in this quadrant there is no defective one. Now we can field with L-shaped symbol like this. You can field with L-shaped symbol. You can field with these three squares by using this L-shaped symbol. Now later again we are divided into number of subparts. For example, here in this case also can in this quadrant is also divided into number of subproblems, divided into equal parts. Here also divided into equal parts. Here also divided into equal parts. Here also divided into equal parts. Now we can solve one by one. Now we can see already these L-shaped symbol filled with L-shaped symbol here. Then here this is the defective one. Now we can fill with L-shaped symbol here. You can see here. Then you can fill with, these are the non-defective cells. You can fill with L-shaped symbol. Here also you can fill with non-defective one, L-shaped symbol here also. Here also filled with L-shaped symbol. Here also filled with L-shaped symbol. Okay, this problem is solved. Now we can see this is the problem, this another quadrant. In this another quadrant there is no defective one. Then how can fill that? How can fill that? Here is already in this L-shaped symbol is here is there. Now we can see you can fill with these three cells by using L-shaped symbol. Okay, now we can see here also can filled with the L-shaped symbol. Here also filled with L-shaped symbol. Here also can filled with L-shaped symbol here like this. Here also you can filled with L-shaped symbol. This problem is also solved. So this problem is solved and this quadrant is also solved. Again here this quadrant also solved by using, here you can see this is, you can here I am already considered the L-shaped symbol. Now these are the three. There is no defective one. Now we can fill with this one. Okay, that is the important one. Otherwise the problem is solved very difficult. But you can apply the divide and conquer strategy. The entire problem is divided into sub problems. Then each and every sub problem you can solve it. Then finally you can find out the problem is, entire problem is solved. Now we can see here is one L-shaped symbol is there. You can fill with this. Here also you can fill. Here also you can fill with. Here also you can fill with the L-shaped symbol. Now this problem is solved. This quadrant is also filled with that L-shaped symbol. Now you can see here in this part already there L-shaped symbol. Now we can fill with here L-shaped symbol. Now you can see you can fill with here, you can fill with here, and you can fill with L-shaped symbol here, and you can fill with L-shaped symbol here. So this is the entire problem is solved. Okay, 8 by 8 entire problem is solved. Now this is the algorithm, you can see. So this is the algorithm. So tiling defective chessboard. Here the algorithm tiling board. Okay, so this is the top row. TR means top row. TC means top column. DR means defective row. DC means defective column. And size of the chessboard. For example, I am consider this is the chessboard. I am consider this is the chessboard. Here in this 8 by 8 chessboard, 8 by 8 and 3, 4, 5, 6. So 8 rows is there. Now we have the 8 columns. Here 1, here 2, here 3 and 4, here also you can divide, here also you can divide. For example, here you can see this is the problem, entire problem. So for example, you can consider any one of the cell is defective one. Now I am consider this is the defective one. Now I am consider this cell is a defective one. This cell is the defective one. Now we can solve this problem. Now we can see here the top row is 0, and top column is 0 column. Initially it is the top column, and this is the top column, this is the top row, 0 0. And defective row, so what is the defective row? Second row, that is 0 and 1. So first row, defective row, and defective column is 0 and 1 and 2. This is the defective column, that is defective column is 2. Now what is the size? Size is 8 by 8 chessboard, so the size is 8. Now the size is 8. Now you can check, see here you can check the condition. If size equal to 1, that means the board is 1 by 1 chessboard. You know already 1 by 1 chessboard, only one defective cell is there. So that problem is small problem, then no need to divide that problem into sub problems. Directly can return that problem, you can solve that problem. Otherwise, tile to use tile plus plus, and quadrant size by 2. So here the size is 8, so 8 by 2, that is 4. Now you can see this entire board is divided into 4 parts, 4 quadrants here. The entire board is divided into 4 parts. Now you can see 8 by 2, that is 4. So this is the 4 by 4 chessboard. Here also 4 by 4, here also 4 by 4, here also 4 by 4 chessboard. Now you can solve that this problem. Now you can see. So first find out the defective one is there or not. Okay, which quadrant the defective cell is there, defective square. Now we can see this is the DR, means defective row. So what is the defective row? Defective row is 0. For example, here defective row is 1. In this case defective row is 1. So defective row is 1, and TR, top row, that is 0, plus quadrant size, Q size, that is 4, and logical AND operator, and a defective column. Also, what is the defective column is 2. Now the defective column is 2 less than top column, that is 0, plus Q size, quadrant size is 4. Now we can check. So here 1 less than 4, the condition is true. Now this is the logical AND, so both the conditions are true, then only the entire condition is true. Now here you can check 2 less than 4, here also the condition is true. That means in this particular quadrant the defective cell is there. Now defect in this quadrant, again you can call that tile board, TR, top row and top column, that is 0, top row and top column, that is here the top row is 0 and top column is 0. Defective row is 1 and defective column is 2. Now the Q size, here initially it is size is 8, now the size is 4, so you can pass the 4. Again you can apply the same thing. Here already the defective one is there, so in this case, okay, so the entire problem is divided into 4. So here it is 4. Now this entire problem, now again here also 4 by 2, that is 2. So the entire problem is divided into 2. So entire problem is divided into 2. Now we can see the entire problem is divided into again sub problems. Here also can divide it into sub problems. Here also can divide it into sub problems. Here also can divide it into sub problem. Like already previous slide you can discuss. So how can solve this particular problem? You know already. For example, in this quadrant, starting in this quadrant, having the defective one, now we can fill with L-shaped symbol here. Then here also we can divide this problem into sub problems. Now in this quadrant having the defective one, now we can fill with this is the L-shaped symbol. Then you can solve this problem. Okay, you can fill with LCM symbol like this. Here also you can see already in this case here LCM symbol is already there tiled. Then so this problem is here, you can fill with LCM symbol here. Here also there, here also there. Now you can see here also there and here also there. Now here in this case in this cell is there. Now we can fill with this one and this one, and here also and here also. Here also can fill with LCM symbol. Now you can see in this problem here also you can fill with LCM symbol like this. Then you can solve it. Here also you can solve it. You can fill with LCM symbol here. Here also you can fill with LCM symbol. Like the entire problem is solved. So by using this algorithm, so that the divide and conquer solution is, so you can see for example this is the defective one, then again this problem is big problem, then this problem is divided into number of sub problems, then solve each and every sub problem. You can combine those their solutions. Okay, like here for example this is a problem defective one. Okay, now we can first you can fill with this L-shaped symbol, this color. Okay, so again this problem is divided into 4 parts, divided into equal parts here, 4 quadrants. So this is the defective one, this black color. Okay, now you can fill with this L-shaped symbol in this here. Now it is solved this quadrant, here filled with L-shaped symbol here, here also filled with L-shaped symbol, here also filled with L-shaped symbol, here also can fill with L-shaped symbol. Now already here in this case here it can fill with L-shaped symbol. Now we can see already here also there. Now we can see you can fill with this one. Then you can solve here. Then you can solve here. You can fill with L-shaped symbol here and here also. Now here also this is the one quadrant. Here already it can fill with this tile. Now we can see, so remaining quadrants you can fill with here L-shaped tile here. Then simply can solve it here. You can fill with L-shaped symbol. Here also can fill with L-shaped symbol. Here also can fill with L-shaped symbol. Now here also can fill with L-shaped symbol. Now already here the tile is already filled. Now we can see these are the 3 quadrants. Now we can fill with like this. Now we can fill any order. So we can fill with L-shaped symbol or trominos like this. So the entire problem is solved. Now the time complexity recurrence relation of above, that is the defective chessboard. So this is the recurrence relation, Tn equal to 4t n by 2 plus c. So how can solve this recurrence relation? Either by using master method or master theorem you can solve directly, or substituted method you can solve the recursive case. Here it is a 4 is there. Now t of n by 2, in place of n here you can substituted n by 2. Now we can see plus c. Here it is, you can call this function again 4 and t. Here it is already n plus n by 2, so that is n by 4 plus c. Now we can see 4 into 4, that is 16t by n by 4 plus here the 4 into c, that is 4c plus c. Again also recursive call 16t here it can see substituted in place of n by 4, and already 4c is there, 4c plus c. Now it is 4 t, already n by 2 is there, n by 4, now n by 8 plus that is c. So you can see 16 into 4, this is 64 t n by 8, 16 plus c, that is 16c, 4c plus c. So you can write here, this is 4 cube t of n by 2 power 3, 8 is can return 2 cube here, plus 16c plus 4c plus c. So recursively can apply the same thing here. It can write 4 power k in k steps, 4 power k t into n by 2 power k. Here you can see here 3, here also 3, so 3 is k here, the k terms, 4 power k t into n by 2 power k plus. So here you can see, for example, c is common now, that is 1c plus 4 square plus and so on. You can write this. So this is in GP. What is the GP formula here? S of n is equal to a into r power n minus 1 by r minus 1. So what is the a? A means the first term. So 1. What is r? So here the 4, here the 4 square, next 4 cube. So the 4 multiples. Now r is the 4, and here it is n is here the k terms. So you can see in this here 3, here it is 4 square, that is k minus 1. Here it is k minus 1 and minus 1 by 4 means 4, that is 4 minus 1, that is 3. So this is the one term. Here you can see 4 power k. Now you can solve this problem. Let 2 power k equals to n. You can apply both sides on logarithms. So log 2 power k, that is equal to log n. Here it is k log 2, that is equal to log n. Already here the log 2 base 2 value is 1. Now the k equal to log n. So k value is log n now. So 4 power k value is log n here. Then n by 2 power k, 2 power k is n. Now t by n by n. So already you know this part. So 4 log n you can also write 4 for log n. You can write 2 log n whole square. So here it is also write n log 2 base 2 whole square. Here the log 2 base 2 is 1. Now here n is there, so n square. Now we can write in place of 4 log n, here you can write n square. So the t n by 1, that is t1, that is only 1, n square into 1 plus here it is 4 power k minus 1 by 3. Here also the term is n square, here also 4 power k, also 4 power k you can write here 4 power log n. like this, that is also n square. So the maximum term is n square. So the time complexity is big of n square. The space complexity is big of n. So this is the recurrence relation you can solve. So the time complexity, can find out the time complexity of defective chessboard is n square, big of n square. Thank you for watching this video.